Hi guys, my name is Peter C. Dogba Jr., mathematics instructor at the University of Liberia and your math tutor. So in my today's video, I'm going to look at differential equations, and particularly I'll be looking at verifying solutions to differential equations. So in the previous videos, we did 3 other problems. So this is the 4th problem that we want to do. The 4th problem says we must verify that the indicated solution is the solution to the differential equation. So this is the solution. Y equals 1 all over 1 minus sine of x raised to the power 1 over 2. I rewrite that radical. Now, in this differential equation, we have one first order derivative. So we must find the derivative of this function, replace it with it, and we replace this y that is given to us in this and simplify as to whether it is equal to 0. So now we found y prime. So y prime, or we say dy by dx, since here is dy by dx. We apply the quotient rule. Quotient rule says we must hold on to the denominator expression, 1 minus sine of x. We hold on to it without differentiating. And then we differentiate the numerator. The derivative of a constant, which is 1 now, is equal to 0. Minus, so we should put a minus sign. We hold the numerator expression and we differentiate the denominator. So differentiating this one, you bring this power down, 1 over 2. You rewrite this expression, 1 minus sine of x. And you subtract 1 from this power. So it's like 1 over 2 minus 1. Then you differentiate inside. So the derivative of 1 is 0 minus the derivative of sine is cos of x. All divided by 1 minus sine of x raised to the power 1 over 2 all square according to the formula. So this 2, we cancel this 2 now. This first one is 0. So it's dy now by dx will just be equal to, so this is 0. So this first one will be 0. You have half right there, right? Half 1 over 2. Negative 1 times this is negative 1 over 2. Times this 1 is negative 1 over 2. Times this cos is positive 1 over 2 cos of x. Then the next one, negative 1 over 2 times this is negative 1 over 2. Negative 1 over 2 times negative is positive 1 over 2. Right? But can we go in here? We cannot. So we cannot say we are multiplying 1 over 2 times this and times this. No, we cannot. Why? Because there is a power that we need to get rid of. So because of that power, we cannot go inside. The only thing we can do is we can multiply minus 1 times this times 1 over 2 times cos of x. So negative times negative is positive. 1 times 1 over 2 is 1 over 2 cos of x. Times 1 minus sine of x raised to the power. Now, 2 times 1 is 2, which is negative. You add it to this one, you divide by the same denominator. You just have minus 1 over 2. All divided by 1 minus sine of x raised to the power 1 now, which is just the same thing. So if we further simplify this one, this dy now by dx is just equal to, now this 2 is within the denominator. This minus 1 minus sine of x is also here as well. This power is negative, so we send it down. It becomes positive, so it's 1 minus sine of x raised to the power positive half. And the numerator is just cos of x. Now what do you observe here? This power is 1, this power is 1 over 2, so we can add the two of them. So 2 times 1 is 2, 2 plus 1 is 3, so I can just rewrite it, thereby saying 3 over 2. So this is our first derivative. So we go back now in the problem and just put it in. So we have 2. So this first derivative now is this one. So it's cos of x all over 2, 1 minus sine of x raised to the power 3 over 2. So this 2 cancel this 2. Minus y now is 1 all over the root of. So I'm going to just use parenthesis now 1 minus sine of x raised to the power 1 over 3, 1 over 2, all raised to the power 3 times cos of x, all equals to 0. So this is now cos of x divided by 1 minus sine of x raised to the power 3 over 2. Right? So if this is multiplied 3 times, you have 1 in the numerator all over 1 minus sine of x raised to the power 1 over 2 or raised to the power 3, which of course if you multiply this now we just give you 3 over 2. So if this 1 is being multiplied by cos, we will just have cos of x all equals to 0. So what do you observe? What do you observe? Cos of x all over 1 minus sine of x raised to the power 3 over 2 minus cos of x all over 1 minus sine of x raised to the power 3 over 2. This is equal to 0, is equal to 0. So it had been verified that y equals to 1 minus 1 divided by 1, the square root of 1 minus sine of x is actually a solution to this differential equation 2 dy by dx minus y cubed cos of x equals to 0. So this is how we find, how we verify differential equations. So thanks all so much for watching. See you in our next video.